Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome with a new clip set video. This one is a nice one. Please, before we start, as usual, please like, share, subscribe, comment if you have, and turn on notification. Please do that before we start. Okay. Here's the question. I need to prove this statement 2 to the 3n minus 1 is divisible by 7 for all positive integers n. Give that a try. It will be solved using indirect proof. Try your best in this one, and then continue to watch how to solve it. Okay, for the indirect proof, we need to prove 3 statements or follow 3 steps. First one, you verify it will be correct at some value of n. Start with the first positive integer would be nice, and then assume that the statement 2 to the power 3k minus 1 is correct. That means it will be divisible by 7, and then prove that if any increment of 1 happens to k, it will be also divisible by 7. Okay, so this is the main 3 steps for mathematical induction, and we'll see how to prove that. First one, I will verify that it will be correct at n equal 1. So by substituting n equal 1 in this, it will get you 2 to the power 3 times 1, which is 8 minus 1. 8 minus 1 is 7. And of course, it is divisible by 7. Okay, that one was easy. You can continue by finding it at 2. That is not necessary, but let's see what is that is equal to 2 minus 1. It will be 2 to the power 6, which is 64. 64 minus 1 again is 63, and 63 is also divisible by 7. So I'm pretty sure that at least for the first few integers, it will be okay. Let's see the assuming. I will assume that this statement here is a multiple of 7 is correct. Just assume that and build the next or the third step on that. This is my favorite step. No steps you do at all. Just assume that the statement is correct for some value k. Now, if we replace k by k plus 1, okay, given that the same assuming from the last step, I will prove now that this statement here is divisible by 7. Okay. I know that this is 2 to the 3k multiplied by 2 to the 3, because if you substitute or distribute 3k plus 3, and of course any sum happen in the powers means it was multiplication, like a power n plus m is a power n multiplied by a power m. Okay, that's minus 1. Of course, 2 power 3 is just 8 multiplied by 2 power 3k minus 1. Okay, that's not clear if that is divisible by 7 or not. So I will try to use the given 2 power 3k minus 1 is divisible by 8. So to obtain that, I will add and subtract 2 power 3k. So I will add 2 power 3k, and I will subtract 2 power 3k. That will not affect the final result, of course, but it will help me to show how that is divisible by 7. First, I will collect these terms as like terms, which are 8 minus 1, which is 7, times 2 power 3k. And I know that the remaining terms, 2 power 3k minus 1, is already divisible by 7 from the given. This part is divisible by 7 from the second step here. What about the other part? It's 7 times an integer, so it's also divisible by 7. Adding 2 multiples of 7 will yield a multiple of 7, of course. Any 2 multiples of 7, when adding, will be multiple of 7, and that's it. So we start by verifying that at initial value, assume that it will be correct at k, and then prove the last one, it will be divisible by 7 for all integers after these 3 steps. this is the main steps for mathematical indirect proof. I hope that you enjoyed the video. And if you have any suggestion with new ideas or new videos, or you have any question, please feel free to comment. And don't forget to share and subscribe and like the video. And see you in the next one. Enjoy.